solving 12 advanced 6.1 photoelectric effect. Which of the following best describes the photoelectric effect? It's not the reflection of light, it's not the emission of electrons when it is heated, and it's not the absorption by atoms causing them to emit visible light. It's eventually the emission of photoelectrons when certain metals are exposed to electromagnetic radiation, or we can just simply say light. The photoelectric effect provides evidence for the particle nature because it's giving, it's relating the energy, it's relating the wave to energy and certainly mass, acting like a mass, a particle. Which of the following will decrease the energy of a photon? We know that E equals to HF or HC over lambda. So in order to decrease E, either I decrease F or increase lambda. So increasing the wavelength and decreasing the frequency. So 1 and 4. The energy of a photon is inversely proportional to the wavelength and directly to the frequency. And the photoelectric effect is that the incident photons have a wavelength that is more than the threshold wavelength. So basically when we have the wavelength is bigger than the lambda 0, this means that F is less than F0, which means that the energy is less than the work function. So in this case, I will have nothing. I will not have any photoelectric effect, and no electrons will be emitted. Which feature of the photoelectric effect supports the quantum photon model? It's not depending on the amplitude, neither with the time of exposure. Eventually, the emission of electrons depends on the frequency, not its intensity. And again, we say that the intensity has to do with the number of photoelectrons that are ejected. Okay, and electrons can be ejected even if the light is below the threshold frequency. So إذا كانت F less than F0, nothing will happen. This means that the energy is less than the work function. In a photoelectric experiment, what is the role of the photocell? The role of the photocell is to generate an electric current لما الphotons strike the metal surface. So the whole thing is to generate an electric current. Which of the following decreases is if we decrease the brightness? So the brightness has to do with the number of photoelectrons. Electrons. So the number of photoelectrons per second traveling in the beam. The same KPI. A light beam falls on a metal surface and electrons are ejected. Which of the following regarding the photoelectrons if the intensity of light is increased? So talking about the number is that the intensity is higher, the number of electrons ejected are higher. But talking about the energy and the kinetic energy, it is only depending on the energy of the light, which is depending on the frequency. So in order to increase the kinetic energy, I have to increase the energy, not the brightness. So it stays the same. If a metal has a work function of 3, which of the following photons can eject an electron? So why? So basically in this case, let me try to find the energy of each. So I'll say 1240 over 300, 1240 over 400, and 1240 over 700. Trying each one, for example, the first. So the first will give me 4.13, the second will give me a 3.1 EV, certainly, and the third energy will give me 40 divided by 100, 1.77 EV. So لما work function is 3, only the energies that are having larger magnitude than the work function will be able to do photoelectric effect. So it's 1 and 2, not 3, because 1.77 is not enough. So 1 and 2 only. What is the energy in EV of a photon that has a wavelength of 620, which is 1240 over 620? My answer will be in EV, and it is 2 EV. Two metal surfaces, A and B, have different work functions such that the work function of A is greater than the work function of B. So this metal of work function A is greater than this metal that has work function of B. If the same light shines on both surfaces, which of the following best describes the difference between the electrons emitted from the two surfaces? So basically, I will send the same amount of energy onto A and the same amount of energy onto B. So he did not mention anything about the brightness. So this means there's no more electrons that will be, or fewer electrons that will be out of A or from B. Eventually, because A has a larger work function, this means after applying E equals to work function plus kinetic energy, the larger the work function with the same energy, the less will remain for the kinetic energy of the electrons. So basically, the kinetic energy of the electrons that will be out from A will be less than those going out from B. So electrons emitted from A have less energy from those from B. That's it. A certain metal work function, I need the relationship between the cutoff for the cutoff frequency. So basically, the work function is HF0. F0 is work function divided by H. Which of the following statements is incorrect? The threshold frequency does not depend on the metal. Yes, each one has its own F0. The emission of photoelectrons is instantaneous process. Yes, it is also a correct answer because it doesn't need much of time. We don't wait it until it is heated or anything. It is spontaneous. It is instantaneous. Photoelectric emission does not occur below the threshold frequency, of course. If it is below F0, nothing happens. The photoelectric current increases when the frequency of the incident light. So by increasing the frequency, I increase the energy. This means by having the same work function, I will increase the kinetic energy, not the current. Photons are incident upon a metal surface with work function 8 and photoelectrons with maximum kinetic energy of 12. I need to find the energy, so the energy is the work function plus the kinetic energy, so 12 plus 8, which is 20 eV. Light of wavelength 300 incident on beryllium metal that has work function of 3.9. Calculate the maximum kinetic energy. So from this wavelength, I will find the energy, which is 1240 divided by 300. Previously, I had it equal to 4.13 in EV. So the energy is the work function plus kinetic energy. Given energy, the work function is a 3.9 plus the kinetic energy. The kinetic energy is only 0.23 eV. Now, a material with a threshold frequency F0 is illuminated with light of frequency 2.5 F0. The maximum kinetic energy of the ejected photoelectrons is. So the work function has HF0 and the energy has HF. In particular, F equals to 2.5 F0. This is what he meant. So H multiplied by 2.5 F0, we need to find the kinetic energy. So applying our formula, E equals to the work function plus kinetic energy. So here I'm gonna replace H, or 2.5 HF0 equals to HF0 plus the kinetic energy. The common factor is HF0, so I'll take it to the other side. So I'll have 2.5 HF0 minus HF0, which is 1 HF0, equals to the kinetic energy. 2.5 minus 1 equals to 1.5 HF0 for the kinetic energy. So 1.5. A photoelectron, photocell has a metal aluminium with a work function of 4.08. What's the stopping potential of photons of energy? 6.4. Strike the surface metal. The stopping potential. So E equals to work function plus the kinetic energy. And then from the kinetic energy, I can find the stopping potential. 6.4 equals to 4.08 plus the kinetic energy. The kinetic energy equals to 2.32 eV, which, because it is an eV, it is equal to EVS. Taking E equals to 1, so also the stopping potential is 2.32 volts. The graph below shows the variation of the stopping potential, the stopping voltage V stopping, in terms of the incident frequency. From this graph, I need to find the cutoff frequency. We agreed that the cutoff frequency F0 is the x-intercept. So it is this one, but not F5. 5 multiplied by 10 to the power of 14. Now, in question number 20, I need to find the work function. To find the work function, it is h of 0. So it is 6.63 10 to the power of negative 34 multiplied by 5 10 to the power of 14 or 15, I'm not sure. Yeah, 14. Which will give me a 3.3 10 to the power of negative 19 in joules. Now determine Planck's constant from the data provided in the graph. So if they force me to use the data from the graph, this means I have to use the values in here. So to find h, I need to find the slope. And not to forget, بما أنه here we have the stopping potential, this means I need to convert by multiplying 1.6 times 10 to the power of negative 19. Now let's find the slope. So I'll use my two numbers here. I'll use the 2 with the 10. So 2 and تحت I have 10 minus. Here I'll use this point which has y equals to 0 and x that is equal to 5. Not to forget that the frequencies, they have 10 to the power of 14. And here we need to put our conversion. Not all the time, but when we're using the stopping potential, and eventually it will be 6.4. Yeah. This one. Now, true or false, light with a frequency below the threshold can eject? No, it cannot. The energy of emitted electrons depends on the brightness? No. The number of eventually depends on the brightness. Increasing the intensity increases the number of ejected electrons? Yes, electrons are ejected with a time delay. There is no time delay. Which has more energy, a photon of ultraviolet or a photon of yellow? So basically, an ultraviolet has a very large energy and a very low lambda. And yellow is it's having a lesser energy. This means a higher wavelength. So which has more energy? The it's lying in the visible. So basically it is the ultraviolet that has more energy. The work function here is 4.31. I need to find the cutoff wavelength. Simply lambda equals to hc over lambda, or I can apply work function equals to 1240 over lambda 0. 4.31 equals 1240 over lambda 0. Not to forget that here I'll have my lambda in nanometer. So basically lambda 0 is 288 nanometer. If photon of energy 5.5 eV is incident, what's the maximum kinetic energy? So the energy is 5.5. The work function given. So 5.5 equals to 4.31 plus the kinetic energy. The kinetic energy is simply the difference, which is equal to 1.19 eV. Question 5. We have a light beam of wavelength 2, 10 to the power of negative 7. So basically this is the wavelength of the light used on a metallic plate of a photoelectric cell, electrons with a maximum kinetic energy in joules. So maybe in this exercise we are more into the hc over lambda, not the 1240 over lambda in nanometer. Find the energy of each incident photon. Given the lambda, I can find the energy, which is here the constant 6.6 10 to the power of negative 34. Lambda is 2 10 to the power of negative hc 3 10 to the power of 8 over lambda, that is 2 10 to the power of negative 7. The answer is in joules, 9.9 10 to the power of negative 19 joules. Now how do I find the work function? Now that I have the energy and the kinetic energy, I can simply find the work function. Replacing everything by its value, the work function is the energy minus the kinetic energy. So it is 9.9 10 to the power of negative 19 minus the kinetic energy that I already have up, 3.9 10 to the power of negative 19, which is only 6 10 to the power of negative 19 joules. Now that I have the work function, the threshold wavelength, simply I need lambda 0. So the work function is hc over lambda 0. Why did I use this equation? Because my energy is in joules. So 6 10 to the power of negative 19, 6.63 10 to the power of negative 34. C, that is a 3 10 to the power of 8 over lambda 0. It will be equal to 3.3 10 to the power of negative 7 meters. This question has the work function of two metals, X and Y. One that is larger than the other. Calculate the threshold wavelength of each. Here I will use this equation for X, that it's hc over lambda of X, replacing everything by its value. 3 10 to the power of negative 19, 6.63 10 to the power of negative 34, 3 10 to the power of 8 على lambda of X. So basically lambda X is, I think, 6 10 to the power of negative 7 meters. I will repeat all of this for Y, hc over lambda of Y, doing the same thing, but here it is 13.2 times 10 to the power of negative 19. Okay, it is 1.5 times 10 to the power of negative 7 meter. That's lambda 0 of each, so lambda 0, lambda 0, lambda 0 of X, lambda 0 of Y. Okay, light of wavelength 3 10 to the power of negative 7 is incident on the surface of the metal. Which of the metal, X or Y, exhibit the photoelectric effect? So I have two ways to solve it. Either I find the energy of this wavelength, which is hc over lambda, 6.63, 10 to the power of negative 34, 3 10 to the power of 8 على 3 times 10 to the power of negative 7. That is equal to 6.63 times 10 to the power of negative 19 joules. This one is bigger than the work function of x, smaller than the work function of y. So only x will exhibit, so only metal x will undergo photoelectric effect. For the metal which exhibits photoelectric effect, calculate the maximum kinetic energy. So we chose x. So the energy is the work function plus the kinetic energy. Simply, it is the difference. So 6.63 10 to the power of negative 19 equals to 3.3 10 to the power of negative 19 plus the kinetic energy. The kinetic energy is the difference, which is 3.3 10 to the power of negative 19 in joules. Question number 7, we have two light sources are used in a photoelectric experiment. When green light of energy that is given, alright, so I'll have the energy is used photoelectron, I have the kinetic energy. I need to find the frequency of the incident light. Given the energy, let me find F. So the energy is 2.64, 10 to the power of negative 18. H is 6.63, 10 to the power of negative 34. F in hertz. F equals to 4, 10 to the power of 15 hertz. Now we need to find the stopping potential. The stopping potential is related to the kinetic energy, EVS. But now that our energy is in joules, so I need to use E as 1.6 10 to the power negative 19, not 1. VS, so I'll have VS equals to 2. Please don't forget the unit of the stopping potential, that is in volts. Find the work function, that is simply the difference between the energy and the kinetic energy. That is the energy minus the kinetic energy, يعني 2.64 10 to the power of negative 18 minus 3.2 10 to the power of negative 19, which will give me 2.32 10 to the power of negative 18 joules. If the stopping potential is 1.5 volt, what is the maximum kinetic energy in joules and in EV? So basically, to find the kinetic energy in joules, it's a bit different than the one in EV. Starting with the easier one, the one in EV, it is E multiplied by VS. But because it is in EV, I will use E equals to 1. Vs is 1.5, so I'll have 1.5 EV. In joules, I will use E as 1.6 10 to the power of negative 19. So it's also the same equation, but E is equal to 1.6 10 to the power negative 19 multiplied by 1.5. That will be 2.4 10 to the power of negative 19 joules. Question number 9. During a photoelectric effect experiment, a student plotted the maximum kinetic energy versus frequency. Use the graph to find the threshold frequency. So again, the threshold frequency is the x-intercept. F0 is 2, not to forget, 10 to the power of 15. Use the data from the graph to calculate Planck's constant. So Planck's constant Alright, so h is the slope, which is equal, I'll choose 2 points. So I'll use this point and this point. So y2 minus y1 over x2 minus x1. 24 minus, على 6 و 12 minus 4. Not 12, 24 minus 6 and 12 with 4. Not to forget that for I have 10 to the power negative 19 وتحت I have 10 to the power of 15, which will give me 6 times 10 to the power of negative 34 joules seconds. If you forgot the unit of H, just go to the formula sheet and get it. Calculate the work function. The work function is HF0. So we're gonna use in this equation the same H we got. Negative 34 times F0 was 2, 10 to the power of 15. The answer is 12, 10 to the power of negative 19 joules. Now the last question for this topic, we just did a little bit of adjustment here before we start. We replaced potassium with platinum. Now this graph represents many metals with different threshold frequencies and all showing the same slope, which means the same F. We need to use the graph to complete the table. Which metal has the highest threshold wavelength? So لما wavelength is the largest, this means F0 is the smallest. And which one has the smallest value of 0? It is the potassium. However, the stopping potential for platinum, so I'll go and check platinum only, when light of frequency 2.25 is incident on the metal. So let me concentrate on platinum. لما the frequency is here 2.25, I'll go and check the stopping potential. But pay attention, it is not 2 EV, لا, it is 2 volt. Because The kinetic energy من شوي قلنا that it is related to the stopping potential by a factor of 1. So it's the same value but different units. Metal with a threshold frequency of approximately 1.1. مين الميتال يلي عنا ال threshold frequency تبعيته is 1.1. It is zinc. So zinc. Finally, we need to find Planck's constant from the graph. هلا you are free to use any line or any line you'd like. I will choose platinum for one reason. لأنه it has the line is passing through two nodes. This one and this one. So هيدا ال coordinates تبعه is 2.25 10 to the power of 15 مع 2 volt. With this line with this point يعني ال x is 1.75 10 to the power of 15 while y is 0. So I'll use 2 minus 0 على 2.25 minus 1.75 all multiplied by 10 to the power of 15. And here مش رح انسى I need to convert from EV to volt. 1.6 10 to the power of negative 19. The answer, حتى لو it is not super accurate, just write it the way you have it. 6.4 10 to the power of negative 34, the unit joules seconds. Thank you.